Yes, class. Is this audible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay, class. So, good evening. In the last class, we had stopped at torque, this topic. Let us quickly just revise this topic. So, see, moment of force is basically torque. That is your rotational analog of force. Whatever work the force is doing, whatever functions of force has to perform during translation motion, that same amount of force, that same amount of work, that same amount of task is performed by torque in case of rotational motions. Now see class. R was a position vector, F is the force that is acting. Now R is the perpendicular position vector, perpendicular distance between the axis of rotation and the line of force. So the torque's formula ultimately becomes torque is equal to R F sine theta, you can say, or R cross F simply, you can say. So I think this much we had discussed. SI unit and direction. This also we had seen. See class here. Radius is SI unit is meters, fine. And the SI unit of force is Newton. So SI unit of this becomes torque becomes Newton meter. This is the SI unit of it. Now numericals we haven't done. So not numerical, some numericals I have given you as an assignment. So those who have completed, those who have submitted, once you submit it, then we can discuss it. Otherwise, see how the questions come from here. See class, like say, let's say this is a rod. This is the line that I have taken because this is the line of force. Let's say F1 force is acting upwards. At this particular point, this is the axis of rotation. Let's say this is rotating and this is the axis of rotation. This is the axis of rotation. This is rotating. So perpendicular distance will be this. This will be the perpendicular distance, that is R1. So see, torque, you can write it as R1 F sine theta. And here you can see sine, this is 90 degree, the angle between R and F, this is 90 degree. So torque will be R1 into F. This will be the answer like this, right? This will be the answer. Suppose, let's say, in this case, in the second case, the force is acting like this. This is the force that is acting. This is F2 force, which is acting straight. And the distance from this is still R1. But class C, for the second, this is first one and this is the second one. See here when we write no R1 F2, make it F1 sine theta. See class, the angle between both of these, the perpendicular vector and the force, both are parallel to each other. So this will directly become R1 F2 sine 0 degree. So this torque makes it 0. So like this, you have to solve the questions on torque. Now, based upon torque, you have numericals which are straightforward, which involves R cross F. So cross product can also be applied. This is R cross F can also be applied in certain numericals if it is asked. One small topic that we have is angular momentum. Let us discuss that. Then we will straight away start with moment of inertia. Now see, linear momentum we have discussed. So as I have said, every topic that you have studied has its rotational analog. Didn't we have the rotational analog of basic displacement? We had it. Basic displacement was what? It was angular displacement, simple velocity, linear velocity, which we say. That became what? Linear velocity. This became angular velocity. Linear acceleration, angular acceleration, everything has its analog. So if momentum is there, momentum will also have its analog. So see, angular momentum. So this is basically moment of linear momentum. The way torque was moment of linear force. So this becomes moment of linear momentum about axis of rotation. Fine, about axis of rotation. So see, angular momentum will become what? Linear momentum is there, P. Remember we did a mass into velocity. We had done this. Linear momentum is the product of mass into velocity. That is the formula of linear momentum. So see class, the way relate it with. But now just convert it. So this is the formula of linear momentum. Keep this in mind. Now come back to angular momentum. So the way torque becomes R cross F. R, perpendicular distance cross the what? Linear force. Same thing here, this will be R, that is the perpendicular distance cross angular momentum. Rp sine theta. R cross P, this will become Rp sine theta. Same thing, R perpendicular will be R sine theta. So you can write this angular momentum as R perpendicular into P. This way also you can write. And even if you want to see it graphically, know how this all these have been written. Same thing, class, the way you have done it. Like this particular point you are calculating, let's say. So at this particular point, this P is there. So if when you will produce it, the perpendicular distance, this becomes the R perpendicular. Fine. This becomes theta. This becomes theta. This is R. This is the origin, y-axis, x-axis, like this. Like this, you can plot plot this graph and write the rest of the things. Fine. And it's an axial vector. Axial vectors, when you are doing vectors, we have discussed it. Axial vectors means that its direction is along the axis of rotation. Wherever is the axis of rotation, no, towards it, it's the direction of it. So since, remember, this is an axial vector. So since this is an axial vector, its direction is along the axis of rotation. It is along the axis of rotation. Wherever is the axis of rotation, there will be the direction of linear momentum. So both these topics have very direct formula coming. So this, just remember the formula, basic formula from it. SI unit will be the same. Whatever is the SI unit for this, for the linear momentum will remain the same. Kg meter per second, right? Because it is mass into velocity. For angular momentum, see, for angular momentum, R is the position vector, P, you know. So that just this meter will get multiplied. Note down these 2 points before we start with moment of inertia, because moment of inertia, once you'll cover moment of inertia, then most of the numericals you will be able to solve it. Why? Because many things we are not able to solve, many types of question which involves a combination of all these topics. It's just because we do not know moment of inertia right now. So let us do that. Let us try to start with it. Then whatever doubt, and yes, class, whatever doubts you have from previous class, please let me know. Coming to the topic, moment of inertia. See, moment of inertia basically means the way we have mass in case of linear forces. In rotational, we use the term moment of inertia. So basically, moment of inertia determines the amount of torque that is acting in a body, right? Amount of torque, amount of angular acceleration, all these things are decided by moment of inertia. So no need to write the definition of moment of inertia. You can just relate moment of inertia with mass. What is the function of a mass? When I'll ask you what is the function of that a mass performs in case of motion. So there is no function as such. It has certain conditions through which it can determine the forces, through which it can determine the acceleration that are acting. So same thing is for moment of inertia. Let me write it. Moment of inertia. So this just determines it's like a qualitative quantity that determines the amount of torque that a rotating body is holding. Amount of torque does not mean the value of torque. When I'm saying amount of torque, it does not mean the value of torque as in 5 Newton meter. No, that can be calculated using the formula simply. No. Moment of inertia means amount in the sense as in how torque is depending. No, I'm saying no, just relate it with mass. Relate it with mass. F is equal to MA. Mass is what? Force per unit acceleration. Right. Force divided by acceleration will give you mass. F is equal to MA. So same way, likewise only determine it. Likewise only determine it. Moment of inertia is whatever function the mass is. But here you have something different. That is the formula is M1 R1 square plus M2 R2 square plus M3 R3 square up till Mn Rn whole square. This is the very shortest formula. See, formula wise, the moment of inertia is very small. We have certain instruments, we have certain cases for which you have to remember. Like for a disk, moment of inertia is different. For a disk, when the axis of rotation is passing somewhere else, that is different. See, in moment of inertia, whenever we determine moment of inertia, you have to choose a reference axis first. Because obviously we are talking about rotational analogs. So an axis of rotation is needed. Now from this axis of rotation, we'll determine the rest of the things like for moment of inertia, right? For moment of inertia of a disk. Let's say the axis of rotation, this is passing through the center of the disk, perpendicular to its plane. And one case is when the disk, I'll show you this. See, let's say this is a disk. So one can be when this is the axis of rotation. Here, this is the axis of rotation. This is the axis of rotation. One is when this is the axis of rotation. Do you notice? This is perpendicular to the plane. This is parallel to the plane. So in both the cases, your moment of inertia will come out to be different. That's why this is dependent on it. So we'll see those through formula only. Just in case if you have it as variable, right? If you have it variable or continuous mass system is given. So dm r square means here you will perform integration. Now, by just looking at the formula, you'll not be able to mark it. Let's take the example. For a few moment of inertia, you have to remember like mr square for one, mr square by 2 for another, mr square by 4 for something. Like this, likewise, you have to remember that we'll see later on. But let us see how to use this, how to calculate moment of inertia. Then I'll tell you those things. Let's say calculate moment of inertia of a ring. Ring means it's a circle about an axis. Axis will be specified to you. About an axis perpendicular to the plane of ring and passing through its center. This means This is a circular ring about an axis perpendicular to the plane. Like this is the axis right now. If I'll draw it in better way, passing through its center. This is the axis of rotation. So let's assume that the radius is r, radius of this is r. So inertia is what? mr square. So this will become, for this circular ring, inertia will become mr square. Simply it will become mr square. But what I wanted to tell you was the plane and the axis of rotation. Like let us calculate the moment of inertia of a rod now. Now you'll be able to use it. This is the direct one, mr square. Let's say mass is m, r is the radius, mr square. Let's use that integration one. Do one thing, note down these few points, then we'll do this dmr square, this one, usage of this. Then we'll see more of the shapes for which you have to note these points quickly. C class. Now, calculate moment of inertia of a rod about an axis perpendicular to its center, passing through its center and perpendicular to its plane. See, this is a rod perpendicular to its plane and passing through the center will be like this, right? So let's say L was the total entire length of this rod. So once after getting divided, this becomes L by 2 and this becomes L by 2. Fine. And mass of the rod, I'm assuming it as M. This is the axis of rotation. Like this. Let's say this is the axis of rotation. So it will rotate like this. Like this. At this axis of rotation. Now, for this, I am assuming I'm considering a very small length, that is dx, whose mass is dm. Entire mass is m. The entire length is L. But just for this small portion, I'm assuming that length is dx, and this is m. So whenever we do, again, yes, one more thing, class. Whenever we solve the numericals of moment of inertia, you have to choose the axis. You have to have the axis of rotation. So if this is my axis of rotation, let me assume that this is x equal to 0. So this will become x equal to plus L by 2, and this will become x equal to minus L by 2. One axis I have assumed. Why? Because through this axis, there won't be any distance. Fine. So this much I have assumed. So the small separation with this length, this small length dx with this separation I have assumed. Now coming to the formula usage, which I was trying to tell you. dm r square, instead of r, let's use x, because here I have, let me take this part as x. Fine. And integrating it from where to where? See, we have to integrate it for the entire rod. So from here, minus L by 2 to plus L by 2. This is not what you are trying to find out. So from minus L by 2 to plus L by 2. Now dm, the problem that here right now is that this is dm. See, mass of length L is what? M. Agreed, all of you? The entire rod's mass is M and the entire rod's length is L. So mass of length L will become L. So it means mass of unit length, this will become M by L. If this will become M by L, then whose mass I'm trying to find out? dm is the mass of what? dm is the mass of this very small element dx. So mass of dx, this will be what? M by L multiplied by dx. Now I have the value. This is exactly the value of dm. Now I just have to solve simple integration through it. So I is equal to integration. Now instead of dm, I will write it as m by L dx. Then I had x square from minus L by 2 to plus L by 2. First, tell me, till here, is it clear to all of you? Any doubts anybody has? Ask me first. I'm asking you till this step, because now simply integration is left. Physics part is still here only. Now simple mathematics we have to involve. So clear to all of you?
Yes, ma'am.
Okay, good. So see, now simple integration will involve what? X square is given. So how do we integrate this? See, x to the power 2 is given. Look here at the side. X to the power 2 is given to you. So this will become plus 1 divided by this term, that is 2 plus 1. That is x square plus 1, this will become. I'll write it now directly since I've told you. Other side, if anybody is still having difficulties in integration, do let me know. So this becomes x cube, right? X square was there. So this x to the power 2 plus 1 will become 3 divided by 3. Limits from minus L by 2 to plus L by 2. And also we have m by L with us, which are constant terms. Now let us put the values of this. M by 3L, keep M by 3L together. This will make our work easier. M by 3L. So this becomes L by 2 to the power 3 minus upper limit in the place of this minus. Now coming to lower limit, that is minus L by 2 whole cube. Fine. L by 2 whole cube minus L by 2 whole cube. So see, I will become what? M by 3L is already there. This becomes L cube by 8 plus minus will become plus L cube by 8. Same thing for this. So 2 times this will become C. ML cube by 3L, and this becomes 2 into 2, right? L by L cube by 8 into 2 times. So 2L cube by 8. So 1L cancels this power, 2, 4 here. I comes out to be what? ML square by 12. And class, don't take it just as a question, take it as a derivation. For rod, it is asked. For many, it is not asked. Like, let me tell you this. Let's say you have a simple ring, simple circle. Not even, I'm not specifying any ring. Let's say this is a ring, a circle that you have. If the axis is like this, then the moment of inertia is mr square by 2. If your circle is kept in xy plane, in xz plane, where this, the axis of momentum is now, axis of rotation is perpendicular. So this is mr square. This is for what? This is not for disk. This is for circle. This is for circular ring. Right. So here, nobody is going to tell you in the question that the value of for the moment of inertia for a circular ring along the axis perpendicular to it is IMR square, and for a ring that is when the axis of rotation is parallel to the diameter, the moment of inertia is mr square by 2. No, nobody is going to tell you and mention you and specify this. These things are just understood, as in they will be directly given to you. So you have to solve it. This is, let's say, a disk I have taken. Both the planes I'm saying. So this is a disk. So one axis will be parallel to the diameter. One axis will pass parallel. So for a disk, moment of inertia for this surface becomes mr square by 2. For this one becomes mr square by 4. This you have to remember. Same thing, coming to cylinder. If you have cylinder, let's say this is hollow. This is a hollow cylinder. This is the perpendicular rotating axis. Just a second. So yes, hollow rotating axis. This is the rotating axis and this is a hollow cylinder. So moment of inertia is mr square, same as that of a circle. But as soon as this becomes a solid cylinder, so moment of inertia becomes mr square by 2. These values you have to remember by yourself. Fine, these values you have to remember. Sphere also, let me tell you, if anything is asked, it will be asked from this part only. So this you can manage it yourself as well. This is a sphere. This is a sphere. This one is hollow sphere. So for hollow sphere, moment of inertia is 2 by 3 mr square. Let's say this is a solid sphere. So for solid sphere, it is 2 by 5 mr square. So these are certain values which you have to remember along with that rod question. Not just this rod. This rod is now a part of your learning. Don't take it just as a derivation or as to how to solve questions on moment of inertia. If you have a rod, say moment of inertia, it will be the same that you're getting right now. Fine, there won't be any difference in it. So this will become, what was it, 2 ml square by 12 you have. And this is ml square by 12. If suppose, let's say the rotating axis was here at the edge, like this is the fixed axis of rotation, and this way rotation is occurring. So here moment of inertia is ml square by 3. This you can do the derivation by yourself. Limits will become x equal to 0 to x equal to L. This will be the difference that will arise. So these values you have to remember. From where did I start? I have started from this, the value ml square by 12 which you are obtaining. This value is not just sufficient for you to remember for your exam. This is not just a derivation as well. This value you have to remember along with the values of all these others. Then only you will be able to solve numericals, because you will be given randomly a circular ring of radius, this mass, this has this something like this. And then you will be perplexed totally as how to proceed. So certain values you have to remember by yourself. Note it down. Wherever you're not able to understand anything, ask me out. I'll help you with it. So from here, you have to write it. See class, a certain dynamics of rotation motion, I'm just listing it, though I have already told you how to convert it. How to convert in the sense, if you have F, you will write it as tau. That is, force will be written as torque. If you have displacement, you will write it as theta. That is angular displacement. But if it comes in formula like dynamics, like torque. So force you have studied, F is equal to MA. Now convert it. Instead of F, tau. Tau is equal to, what did I say? Instead of mass, you will write. What should come, class? I have told you instead of mass, what is the rotational analog of it? Yes, class, just now the topic you have done, moment of inertia. Instead of mass, no, right, moment of inertia. And A is the linear acceleration, so angular acceleration will be alpha. This is a formula that you can use. Momentum is equal to mass into velocity. So angular momentum. Yes, Jania, state the formula. Instead of mass, what should come? Yes, Jania, try it. Tarif, Mohammad Tarif. Instead of mass, what should come? Just now I have told you all. Are you there in the class, both of you? Jania and Tarif. At least respond with a yes or no if you're present. Okay.
Is it
Abdullah, you try. Mass, rotational analog of mass. What did I tell you? Just now, look at the first part, all of you. Those who are not able to answer, see the first part. What I have written instead of mass. It means you all are not paying attention in the class. Terim,
Yes, ma'am. Instead of mass, moment of inertia.
perfect. What are we studying? Continuously, we have been studying this only. The definition of moment of inertia only I have told you that it's the rotational analog of mass. This is a way to construct the formulas. How many formulas can you remember? How much can you remember? At least remember the linear one and keep on converting them. Linear velocity, angular velocity will come. Linear displacement, angular displacement will come. Linear acceleration, angular acceleration will come. Force, so torque will come. Like this, you have to construct. I hope this is clear to three of you, Jania, Tarif, and Abdullah, how to make it. So this will become, instead of M, I will come. Yes, Terim, please complete this. Instead of V,
Ma'am, instead of V, angular velocity will come.
angular velocity, that is omega. Perfect. So L is equal to I omega. So this formula you will use. Third, work done. See, if work done is F dot S, that is force into displacement. So in rotation, Talha, instead of force, what should I write? Talha,
yes, ma'am.
instead of force, rotational analog of force.
Torque.
Yes, correct, torque. And this is linear displacement, so angular displacement will come. That is tau dot theta. This is how you write it like. Fine, tau dot theta. Finally, let's see kinetic energy. Kinetic energy is half mv square. This is how we write the formula of kinetic energy. Yes, Waziha, can you complete this? Instead of, see, half will remain. Instead of mass,
I omega square.
I omega square. Perfect. So these formulas you have to use. Let me discuss a question with you. Then it will become clear. A flywheel of mass 25 kg has radius of 0.2 meters. What force should be applied tangentially to the rim of the wheel so that it acquires an angular acceleration of 2 radian per second square? See, this is a complete question. A flywheel of mass 25 kg. So not moment of inertia, mass, linear mass. So M is given to you as 25 kgs. Has radius of 0.2 meters. So the radius is given as 0.2 meters. What force, linear force it is asking, should be applied when angular acceleration is given as 2 radian per second square? So C class, in these cases, in such cases, you require the usage of formulas of what we have done right now. Why I was emphasizing so much to all of you that you all should remember the formula is because of this only. Now see, M, R, alpha, F, there is no single formula which can connect this, right? But see, force is equal to what? Force is R cross F. Sorry, force I'm saying. Torque. Torque is R cross F. But we don't know torque. But right now we have discussed the fact that torque can be written as, instead of mass into acceleration, it can be written as mass, moment of inertia into angular acceleration. Just now remember we had seen I alpha. Instead of MA, it can be written as I alpha. Now, flywheel is given to you. Flywheel is what? It's a disc. So disc, and when nothing is mentioned, no axis is mentioned, you take the standard axis as this axis, the perpendicular axis, this one. So that case, consider it. So, and for moment of inertia, we require M and R. So M and R are given, alpha is given. So we can easily calculate. So see, what will be the moment of inertia of a disc? Moment of inertia. Please understand this question. If you'll not understand this, please ask me. I'll repeat it. It's a very important question. Moment of inertia will be what? I will be mr square by 2. So torque becomes mr square by 2 into alpha. Keep the value of torque here. mr square alpha by 2 is equal to r into f. 1r gets cancelled. Now mr alpha, we have the formula for it. So force will become what? Force will become masses. How much was it? 25 kgs. Radius was 0.2 meters. Angular acceleration was 2 divided by 2 was in the formula. So 2 gets cancelled. 5. Right, this will become 5. So this way, see how we have got 5 Newton. Understood? This way we have got 5 Newton. Like this. This is how such numericals are handled up in this. Note this part down, this conversion part and the question. So any question can be asked. And everything that you have studied till now, it can be related. Like work energy theorem, if somehow work energy theorem is asked, so that will be change in kinetic energy here also, but change in kinetic energy's formula will become different, half I omega square. Understood this? Till here you have to note down this. class, see, last topic for today, then I'll wind up the class, is the conservation of angular momentum. Because this topic is important, so important as in, no, the formula you will find it easy. Formula is easy, you'll be able to solve it also. Numericals also do not come that are difficult. This, let me tell you very clearly. But the application-based questions are a lot asked. Easy, this topic is easy. Conservation of angular momentum, much easier than whatever you have studied. Conservation of angular momentum. So when do we say linear momentum is conserved? Whenever the external force is not acting. So when do we say angular momentum is conserved? When external torque is not acting. The external torque is zero. So it means rate of change of linear momentum will also be zero. Rate of change of angular momentum will also be zero. So it means if rate of change or angular momentum is zero, it means angular momentum is constant. So if no torque is acting in your system, angular momentum remains constant. This is it. Now, what is the formula of angular momentum? I omega. Linear was mv. So m became I, v became omega. L was I omega. This becomes P was mv. So L becomes I omega. Try to remember the formulas like this. Otherwise, class, this will become very confusing. I, v, omega, alpha, where to put what. Just keep on converting it. So this remains constant. It means I1 omega 1 is equal to I2 omega 2 is equal to I3 omega 3. Like this, their product is constant. Moment of inertia multiplied by angular velocity. So angular velocity and linear and moment of inertia, their product is constant. So if I omega is constant, tell me one thing, class. If I increase omega, if I increase moment of inertia, I have to anyhow decrease the angular velocity. See, class, I omega is, let's say, 6. Let's say I is 1, omega is 6. So 1 into 6 gives 6. Suppose I increase I, moment of inertia. I make this instead of I make this as 2. So can I still keep omega the same? Do you see this is not constant now? This has increased. We cannot keep it like this. If this is increased, then this has to decrease. If I have increased I from 1 to 2, I have to decrease omega from 6 to 3 so that this term remains constant. So if I increases, omega decreases. If I decreases, omega increases. Do you understand this part, class? This is what the conservation of angular momentum. If moment of inertia increases, angular velocity decreases in order to conserve angular momentum. If moment of inertia decreases, angular velocity increases in order to conserve angular momentum. Angular momentum has to be conserved at any cost when external torque is not acting in your system. Like this example, 1 into 6 is 6. But if I increase this, 1 into 6 was 6. If I increase this to 1, from 1 to 2, I cannot increase this from 6 to 7, or I cannot keep it constant as well. I have to decrease it to 3, then only this gap will be equal to 6 still. Fine. So there are numerous applications for this. Let me tell you in brief. One example is the rotation of Earth. One application of it is the rotation of Earth. See, when the Earth rotates, there is no, in an isolated system, if you talk about the applications of it. So first application involves rotation of Earth. So in rotation, this part, this is your homework to write all these statements clearly. This is just I'm explaining. See, if Earth shrinks, let's say Earth decreases, Earth's moment of inertia decreases, then what will happen? The angular velocity, angular spin of the Earth will increase, so that angular momentum will remain conserved. One is, you have seen those dancers are there. See, what do? They have their arms stretched out like this while dancing. They have their arms stretched out. When they bring their arms closer to their body. That decreases the radius, and so it decreases the moment of inertia. So their angular velocity increases. Even you can notice when you are spinning, spin like this and spin like this. Here you will be able to spin faster because moment of inertia has been decreased. So in case of dancers, you will see this. Here I is more, so omega is less. But as soon as they'll bring their arms near their body, that is moment of inertia is decreasing. So angular velocity, this will increase now. So if they have to increase their angular velocity, they'll bring it closer to their arms like this. One more example is there of ice caps. See, ice caps are there on the poles of Earth. If all the ice caps that are present on Earth, this last example is of ice caps. If the ice melts, so what will happen? Mass will increase, so moment of inertia will increase. So angular velocity of Earth will decrease. If all the ice caps that are present, no, because of global warming, this is a very rising issue in the countries. Because of this only, ice caps are melting. So if ice caps are melting, let them melt. How is it affecting you? It is affecting not just on a smaller level for the people who are residing here. It is affecting on the whole planetary level. That is, the angular velocity of Earth will decrease. Slow rotations will occur of Earth. Like this, you have various applications of this. Your time, very small, little time is there left, no? Quickly note it down. This you have written it, no? From here, note it down. When you will write it, just text me done. One last topic is left, that is rolling motion. So we'll complete the syllabus by Monday, and then we'll start with the next chapter, gravitation. Class, one thing, the backup class on Friday will be on the same timing. Like for Indian timing, it is 7:30, your class. So 7:30 to 8:30, I'll take the class. So for 7:30, it is 5 o'clock as the KSA timings, I think. So KSA timing will be 5 to 6 time. I'll take the backup class. This Friday, the backup class will be there. And class, your rotation is going to get over. So on next Wednesday, you will have the test of rotational motion. Fine. Center of mass was supposed to occur. I didn't take the test of center of mass. So instead of having the entire lesson, if you want, I can break it into parts, or if you wish, I can give the entire syllabus. So let me know what do you all want. But on next Wednesday, that is 30th, you have to give a test. So just let me know if you are comfortable with the entire lesson, or you just want center of mass and torque, very few, just the chapter to be divided into two. If you people are not saying anything, it means entire lesson you all are agreeing. Then the entire lesson I'll take it. Okay, divided into two parts. Yes, Fazia. Fazia, saying something?
Yes, ma'am. It should, ma'am. The entire lesson is too hard for us.
Entire lesson will take time. Then okay, let's keep it center of mass. Let's keep it just center of mass. That is fine by all of you, I think. Slowly we'll complete rest of the test. Yes. Center of mass. Should be prepare that well, all of you. And all of you should attempt. Last time only Waziha and Abdullah have attempted. All of you should attempt center of mass test. I'll take them.